All right, let's have a look at question 7c. Now, they're telling us to use the discriminant and the concavity to state how many zeros the function has without drawing its graph. Zeros is x-intercepts. Now, you know that the discriminant is b squared take 4ac. For this question, we've got a equals minus 2, b equals positive 5, c equals negative 4. So our discriminant is 5 squared take 4 times negative 2 times negative 4, which is going to come out as 25 take 32. So which is like negative 7, which is less than 0. So no x-intercepts. We didn't really need the concavity for this question, but let's have a look at the concavity. Because we've got a minus 2, a equals minus 2, so it's a SAD, which means concave down. Let's now have a look at question 8. We've been told to consider the parabola 8a with equation y equals negative x squared plus 2x plus 3. And we're going to use algebra to find, I'm just going to do 8a number 2, the intersection of that one with y equals 4. So if I know y equals negative x squared plus 2x plus 3 and y equals 4, all I have to do is substitute this value for y in here. So all I'm going to say is 4 equals negative x squared plus 2x plus 3. Quadratics are always easy to solve when you have 0 on one side, so I'm going to take that 4 over to the other side by subtracting. Negative x squared plus 2x, positive 3, take 4, negative 1. And now I'm going to use my quadratic formula. A equals negative 1, b equals positive 2, c equals negative 1. So x equals minus 2 plus minus the square root of 2 squared take 4 times negative 1 times negative 1 all over 2 times negative 1, which is going to give me negative 2 plus minus, under that square root it's actually going to come out as 0 because I've got 4 and I'm minusing 4. So negative 2 over negative 2, x equals positive 1, only 1 intercept. With the line y equals 4. That's it. So that's the x-coordinate of the intersection point with that. You don't have to do this. I'm now just going to sketch it so you can get some kind of idea. I'm not doing an amazing job. But this essentially means that this is the line y equals 4 and the quadratic kind of goes like that. Well, you don't need that. I'm going to get rid of it so it doesn't confuse people who aren't watching the video. Oh, B, graph the situation. Gosh. Okay. So, I actually need to graph y equals 4 and graph y equals negative x squared plus 2x plus 3. So let's have a look at negative x squared plus 2x plus 3. Well, we know it's concave down. We know the y-intercept is at y equals positive 3. The x-intercepts, x equals minus 2 plus minus the square root of 2 squared take 4 times negative 1 times 3 all over 2 times negative 1. So x equals, that ends up as 4 plus 12, which is 16. So I've got minus 2 plus minus 4 over minus 2. So negative 2 plus 4 is positive 2 over negative 2 is minus 1. And negative 2 take 4, which is negative 6 over negative 2 is positive 3. Okay, now all I need to know is the axis of symmetry. x equals minus b onto a, so x equals minus 2 on 2 times minus 1, so it's x equals positive 1, which is also halfway between negative 1 and positive 3. Y coordinate is y equals negative 1 squared plus 2 times 1 plus 3. So negative 1 plus 2 plus 3, y equals 4. And now I can sketch. I'm going to move all of these over a little bit. Oh no, my minus b got left behind. There we go. Okay. Oh, come on. Okay, so I'm going to sketch this quadratic. So I've got y equals 3, and I've got x equals minus 1 and positive 3. And my axis of symmetry is 1 and 4. So it's going to turn around here. So it's going to go like that and like that. And the line y equals 4 is actually literally just a line along where y equals 4, funnily enough. So it is along here. So that's why it touches it exactly once. That's actually where it turns around. So this dark blue line was y equals negative x squared plus 2x plus 3, and the purple line was y equals 4, and they touched exactly there.